everybody agrees is planet Earth, very good. Any guesses what kind of technology we have circling Earth looking down taking pictures so we can put in this image? Satellites, very good. If you look at the dictionary for the definition of a satellite, there are several different definitions, but they're all basically the same idea. A satellite is a smaller or a lesser object that circles or escorts or travels with a larger or more important object. So as I am circling around you right now, I am a satellite. We have natural satellites and artificial satellites. Can anybody give an example of a natural satellite? The moon. Everybody agrees the moon would be a natural satellite? Is that the moon? No, that's no moon. It's a space station. There's the moon. NASA has been studying the moon since the ABC began. When Congress created the National Aeronautics and Space Administration on October 1st, 1958, the agency was given several directives, and the first one was the expansion of human knowledge, phenomena in the atmosphere and in space, and so they began with the moon. And we'll come back to the moon in a couple of minutes, but just to give you a different way of thinking about satellites, here is the sun. Can anybody name a natural satellite of the sun? Venus, planet Earth, any of the planets, because they're all smaller objects orbiting a larger object, the sun. So technically, you were sitting on a satellite. But usually when we think of satellites, we think of artificial satellites. Artificial satellites circle the Earth looking in one of two directions, either looking down towards the planet, doing what we call Earth science, or they're looking away from the planet out into the universe, doing what we call sky science. Combine Earth science and sky science, and together you get planetary science. In this example, you see satellites in various orbits. Some of them appear not to be moving at all. Those are in a geostationary orbit, 22,000 miles or 36,000 kilometers above Earth. Far enough away so that as the Earth rotates underneath it from west to east, they always go to the same geographic location. So that orbit is very popular with communication satellites. Other satellites you see orbiting to the north, to the south, going over the poles, and that's called the polar orbit. To illustrate how we might use those different orbits, let's say we have a weather satellite we want to put into space. If we put our weather satellite in geostationary orbit, 22,000 miles or 36,000 kilometers above Earth, it's always over the same location. So if we want a picture of that location, all we have to do is transmit a command, and a few seconds later we get back that picture. But it's always the same location. So if we would rather paint a picture of the entire planet, we put our weather satellite in a polar orbit. As it orbits to the north and to the south about once every 100 minutes, the Earth rotates underneath it from west to east. So over the course of the day, it paints a picture of the entire planet, as you see here. We in Florida really like weather satellites, especially when it's hurricane season. This example shows you hurricane tracks during a 55-year period from 1950 to 2005. I'm going to pause this. I'll start on this side, come to the other side in just a moment. You can see how many of our hurricanes begin off the west coast of Africa. So we have weather satellites watching that region for the evidence of